So question 35, we're given a quadrilateral PQRS, and it's given us vertices with the coordinates, and it says prove that PQRS is a rhombus. And then it also says here the use of the set of axes on the next page is optional. So I think it's always good if they do give you a graph. You can also use the graph at the back of the regents, but if they do give you a graph, why not just sketch it out so you can see a visual? So let's plot these points. So P is -2, 3, so it's to the left 2, up 3. And I'm going to label that point right away so I don't forget to label. Q is 3, 8, so to the right 3, up 8. That's Q. R is 4, 1, so to the right 4, 1, 2, 3, 4, up 1. And S is -1, -4, so to the left 1, down 1, 2, 3, 4. Okay, so now I'm going to connect these points to make it a rhombus, because that's what we're trying to prove. So it is a rhombus, but we just have to prove that it is. Okay. So now we know that the properties of a rhombus, we know that the diagonals bisect each other, and we also know that all 4 sides are congruent. So we're going to prove that PQRS is a rhombus by showing that all 4 sides are congruent. So to do that, I'm going to use Pythagorean theorem. So I'm going to do side PQ first. I'm going to go up. I'm going to make a right triangle that connects P and Q together. And then I'm going to count those units. So from P to this top point, it's 1, 2, 3, 4, 5. And then from this top point to Q, it's 1, 2, 3, 4, 5. And here's my right angle. So I know the side opposite the right angle is my hypotenuse. That is my C. So now I'm going to use the Pythagorean theorem. So that's A squared plus B squared equals C squared. And I'm going to plug in my numbers. So I know my legs are 5, and PQ is my hypotenuse because it's across in the right angle. So I'm just going to plug in those numbers. So 5 squared plus 5 squared is equal to C squared. When we simplify this down, we're going to get 25 plus 25 is equal to C squared. 25 plus 25 gives me 50 is equal to C squared. And lastly, we want to get C alone. We want to get rid of that 2. So I'm going to take the square root of both sides. I'm going to undo it. And I get C is equal to, the square root of 50 comes out to a decimal. So you can either write the decimal out, or you can just leave it as the square root of 50. Does not matter for this problem. There's no directions about rounding or anything like that. Okay, so now I know that C stood for PQ. So I'm just going to plug my PQ back for C so I know what length PQ is. Okay, so now we're going to do that for the rest of them. So now here's QR. So I'm going to make a right triangle with QR. There's my right angle, so my C is going to be my side QR. So from Q to the right, that's just 1 unit. And from this point down, it's 1, 2, 3, 4, 5, 6, 7. So I know 1 and 7 are my legs. So again, I'm going to use A squared plus B squared is equal to C squared. And I'm going to plug in my numbers for my legs. It doesn't matter which order. When we simplify this down, it's going to 1 squared is just 1, plus 7 squared is 49, is equal to C squared. Then I'm going to combine, so 49 plus 1 is 50, is equal to C squared. And then just taking the square root on both sides to undo that C squared. We get C is equal to the square root of 50. So therefore we let C be my side length QR. So QR is equal to the square root of 50. So now we know both PQ and QR have the same side lengths. They're the same size. So now let's check the other two. So here we have SR. I'm going to make my right triangle. This is my hypotenuse. It's across from the right angle. So from R down to this point, it's 1, 2, 3, 4, 5. And then from S to the point, it's 1, 2, 3, 4, 5. So the same numbers at PQ. So I'm doing A squared plus B squared equals C squared. I'm just showing my work to prove that it's right. My legs are 5. 5 squared plus 5 squared we know gets us to 50. So 50 is equal to C squared. Lastly, just taking the square root of both sides, we get C is equal to the square root of 50. And thus we said our C was SR, or RS. It does not matter which way you write it. So our RS is equal to the square root of 50. So now we know all three sides are congruent. So now let's just check this one last side. So I'm connecting P and S to make a right triangle. From S to this meeting spot, that's 1 unit. From this meeting spot to P, it's up 1, 2, 3, 4, 5, 6, 7. Same numbers as QR. And I'm just going to show my work just to prove that this is a rhombus. So my 1 and my 7 are my legs. And my C squared, across from the right angle, is my side PS. We know 1 squared plus 7 squared gives me 1 plus 49, which gives me 50. So I have 50 is equal to C squared. Get rid of that 2, take the square root, get C is equal to the square root of 50. So therefore, side PS is equal to the square root of 50. Okay, so now we just have proved that all the sides are equal. So our last step is just to write a sentence to show our understanding that how we know it's a rhombus. So we could say PQRS is a rhombus because all side lengths are congruent. And that's a property of a rhombus. Okay. So now there's another part to this question. It says prove that PQRS is not a square. So PQRS, we can kind of already see it's not a square because we know that in a square, all the angles are right. So by knowing that piece of information, even just seeing this visual, we know how we want to prove this. So we know that in a square, they need to be right angles. So what we can do is we can find the slope of each line and show that they're not perpendicular to each other, because we know perpendicular slope equals 90-degree angles. So let's find the slope of PQ. So remember, slope is rise over run. So the slope of PQ, you can also write out slope of PQ. It's up 5, and then to the right 5. 5 divided by 5 just gives me 1. You can also go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and that shows you that the slope is 1 as well. But since I have these numbers here already, I'm just going to use these. All right, so the slope of PQ is 1. So that means I want the slope of QR to be -1 if it's to make it 90 degrees. All right, so let's find the slope of QR. So remember, it's rise over run, but in this case, we're falling, or we're going down. So it's down 7, and then to the right 1. So down 7, to the right 1. So down 7, that's a negative, and then to the right 1 is a positive. So -7 divided by 1 is -7. So right from there, we see that these are not negative reciprocal slopes. So therefore, we don't have 90 degrees. But I'm just going to do it for the rest of them. It's always good to show extra work. So the slope of RS is equal to, so we're not rising, we're falling. So I'm falling 5, so that's -5. I'm going down. And I'm going to the left, -5. So going to the left is a negative. -5 divided by -5 gives me 1. And lastly, SP, the slope of SP. So I'm rising 7. Here's my number 7. So I'm going up 7. And I'm going to the left, -1 though. 7 divided by -1 gives me -7. Alright, so now we have shown our work, so now we just have to write a sentence to show that we understand why PQRS is not a square. So we can say, since the slopes are not negative reciprocals, then the lines are not perpendicular. Therefore, PQRS is not a square because its angles are not 90 degrees. And that's it. So remember, you're just showing your math and just writing a sentence to sum up what you know and what this shows. And it's also, like I said before, it's good to show a visual because right from here we already know it's not a square, and that helped us to determine that we can show that the angles are not 90 degrees. And that's it.
This is Frida, and Frida is probably in air traffic control. Let me read you the question and explain what is going on. Frida, who is training to use a radar system, detects an airplane flying at a constant speed and heading in a straight line to pass directly over her location. She sees the airplane at an angle of elevation of 15 degrees and notes that it is maintaining a constant altitude of 6,250 feet. 1 minute later, she sees the airplane at an angle of 52 degrees. How far has the airplane traveled to the nearest foot? And if you don't know that this is strictly a trigonometry question, you are either sleeping or really confused. Probably you're really confused. So, but if you got it, great. I'm actually going to search for a plane because I am a horrible drawer. So I actually want to find myself a plane, airplane. Let's see. Which one's good? That one will do. A Boeing 737 aircraft. Sweet. Okay, I'm going to shrink this down here. That is god-awful. Shrink it down, and we're going to... Nope. And I want to flip this. Flipped it left to right. Awesome! Nice, we got 2 airplanes. So, let's go ahead and draw ourselves 2 triangles. Well, how do we do it? Or how do we draw the diagram? So, that, in my opinion, that was the hardest part of this question, to get the figure going and draw it. So, basically, there's an airplane at a starting position, and the height is 6,250 feet in the air, okay? It's traveling in this direction. The plane then all of a sudden is over here when Frida observes it yet again. So that means that it is still the same height, it just traveled a distance. Doesn't matter, right? Now, these are where your 2 triangles come in, folks. Right there, those are your 2 triangles. So these are both right angles. So the plane traveled from here to here. I'm going to call this distance X. All right, I'm actually going to highlight this. I'm going to call this distance X. I'm going to call this distance and this distance 2 different letters. I'm going to call this Y, and I'm going to call this Z. And you'll see why in a moment. The little angle, the little baby angle, is 15 degrees, and the big one is 56 degrees, okay? So how do we do this? Your goal in essence, is to get this here. But we need to use the pink and the blue highlighting marks to get x. So this is what we're supposed to do. To solve for x, we need to do the following thing. Take x is equal to the letter z, or whatever the length of z is, and subtract y. The problem is we don't know what z and y are. We have to use that by using trigonometry. Let's go ahead and do it. I'm going to shrink this down because it is taking up a lot of room. Okay, not too bad. So what I'm going to do is I'm going to take, or first things first, I'm going to write down a SOHCAHTOA because I know I'm working with it. Okay. So in reference to the little angle 15 over here, we're given 6,250. That is called your opposite side of that triangle. The side next to it, which is your z, is called the adjacent side. We're using O and A. That means that we're using tangent. So what we're going to do is we're going to solve for z first. So I'm going to take the tangent of 15 degrees. That equals the opposite side, which is 6,250 feet, divided by the letter z. I don't know what z is. I'm trying to find that out. So we're going to cross multiply. So we get z tangent of 15 is equal to 6,250. To solve for z, you're going to divide by the tangent of 15 on both sides. And we get z is approximately equal to, now when we plug this into our calculator, make sure your calculator is in degree mode. When you plug this into your calculator, you get the following. So control division, 6,250 divided by the tangent of 15 degrees. Make sure your calculator is in degree mode. We get 23,325.318. I'm going to round that off. So z is approximately equal to 23,325.32. That, ladies and gentlemen, is the distance in feet from here to here. That is this whole distance, okay? So now what I'm going to do is I'm going to use the other triangle. I'm going to use the other little, the smaller triangle to calculate what the distance is for y. All right, so let's go ahead and do that. Sorry for my sloppy handwriting and my highlighting business. That's not working right. Okay, I don't know why that's not working. Whatever. All right, so again, we're using tangent, opposite, adjacent. Adjacent side is actually this now, the little guy. Adjacent, and this is still, okay, this side is still 6,250 feet because it's maintaining its altitude. Okay, so let's go ahead and solve for y. Let's go ahead and solve for y. So we're using tangent still. So now it's just a different degree measure. The tangent of 52 is equal to 6,250 feet over y. Cross multiply and solve. Y tangent of 52 equals 6,250. Divide by the tan of 52. Divide by the tangent of 52. Tan of 52's cancel. When you go to your calculator, control division, 6,250 divided by the tangent of 52. You get 4,883.04. So y is approximately equal to 4,883.04. Okay, now remember what I said before. So you need to solve for x. To solve for x, you take z and subtract y. So we're taking 23,325.32 minus the 4,883.04. Your goal is to try to find the distance traveled from this point to this point. So when you plug that into your calculator, just take my word for it. You get an answer when it's rounded to the nearest foot. You get 18,442 feet. Ladies and gentlemen, that is the length of x, the distance that the plane has traveled from point A to point B. Okay? That's how you do the first part.